Today we'll be talking about perpendicular and parallel vectors. So I'm going to show you examples of what perpendicular and parallel vectors look like. And I'm also going to show you common misconceptions when it comes to what parallel vectors are. So perpendicular slash parallel vectors. So what is a perpendicular vector? Well, math teachers like to say this word called orthogonal, which is synonymous to perpendicular. They mean the exact same thing, but I'm not going to say orthogonal. Your math teacher may say that, but what I mean by perpendicular, I just mean orthogonal. So let's say you have a vector that goes along the x-axis, the y-axis, and one that goes along the x-axis. This is perpendicular because it forms a 90-degree angle. And what if you have a vector that goes straight north east and one that goes straight northwest? Well, this is perpendicular because this forms a 90-degree angle. So any two vectors that have where the shortest angle is 90 degrees is perpendicular. And what I mean by shortest is you can technically count this side as an angle. This is like 270. But whenever you're talking about vectors, you just count the shortest angle. So let's say you have like a vector that goes like this. Which angle is shorter, this one or this one? Well, the first one was shorter. So you're just going to count this angle when you're talking about the angle between the vectors. And I'll just give you an example of what these coordinates are. Like this would probably be like something like, I don't know, 2, 2. And this would be something like negative 2, 2. So this could be an example of a perpendicular vector. I'll write one more. Perpendicular vectors aren't too hard to grasp. This could also be an example of a perpendicular vector. So what I mean by these vectors is that this one would be 2, 2, correct? And this one would be 2, negative 2. But the thing about vectors is that they can start at any point. Basically, vectors are a set of directions, not an actual line segment. So this line segment isn't from 0. So this is not a line segment from 0, 0 to 2, negative 2. In fact, vectors are a set of instructions of how much displacement or how much you move or how much force you're applying in a certain direction. So this right here could still be a perpendicular vector. And the reason why is if you start them both at the same point. So let's say this is like point, I don't know, 1, 3. And this is 3, negative 2, right? These start at different points, but what if you start these vectors at the same points? And let's actually just write the components of the vector. This is 2, 2, and this is, let's say, 2, negative 2. So what if they both start at the origin right here at 0, 0? Let's draw the vectors with a different color, starting at the origin. And now here's the thing, these are still 2. These are still 2, negative 2, and this is still 2, 2. But now they form a 90-degree angle. So even though the vectors can start at different places, and let's say this is like another point, 2 different points that describe a vector. This is point P and this is point Q, right? This describes a vector, and that description of a vector will be represented with PQ, with the little arrow above it. Even though vectors can start at different points, as long as you just all start them at 0, 0, they will form a 90-degree angle if they are perpendicular or orthogonal. So remember, vectors aren't line segments. okay? You could think of them as coordinates first. Like, you could think of them as this right here, 2, 2, right? So 0, 0. But they aren't just that. Remember that. Remember, they are just a set of steps of which direction to go. And to be more precise, they have a magnitude and direction. And that direction and magnitude determines where the components. And what I mean by the components, I mean by the x and y values of the vector. So what are parallel vectors? Well, parallel vectors are any vectors that just go in the same direction. So it doesn't matter if the angles are, wait, actually the angles would be the same, yeah. But they would just be in the same direction. And also, vectors that start in different spots but are parallel are still parallel. And the reason why is, let's actually change the color of this. And the reason why is if you started this vector right over here at down here, what do you get? They're still parallel. They overlap each other. So when vectors can overlap each other like this while having the same starting point, they're parallel. And what I mean by overlap is that they have the same direction. That means they make the same exact angle along any axis that you're comparing it to. So let's say we're comparing these two red and green vectors along the positive x-axis. I'm going to use green for the green angle, for the green vector's angle. I'm going to use red for the red vector's angle. So what would this angle be about? I'd say about 30 degrees. What would this red angle be about? It has to be the same if they are parallel. And the reason why is because if they didn't, then this would eventually, if this was like 31 degrees, this would eventually diverge further and further and further away from the green vector. So when they're parallel, when vectors are parallel, they'll form same angle along some axis that you're comparing to. If you're comparing these vectors along, let's say the direction says find the angle between green vector and the y plus axis, then this would be 60 degrees. And that's not good. We're talking about the green vector here. This would be 60 degrees because 60 plus 30 is equal to 90, and axes form 90-degree angles. So what's a little confusing about parallel vectors is that they also are parallel if they go in the opposite direction. So this vector, and this vector are still parallel. And the reason why is because, well, they still have the same direction technically. You can say that their magnitude would be negative. So let's say you have a vector that is green here, 45 degrees with the x plus axis, or the positive x-axis. And it's parallel with red, correct? Let's call the magnitude here 5. Not 50, 5. You can have the same exact vector going in the opposite direction, right? And this is still a straight line, is it not? And the reason why it can be in this opposite direction is technically, I guess you can call this red vector a negative magnitude compared to green, but usually your magnitudes will be positive. So the direction isn't only in the same direction, facing the same direction, but the very fact that they are going in the same direction, but in the negative way. So what I mean by negative way is that if this 5 kept decreasing, so now this vector is 4 here, has a magnitude of 4, now this vector has a magnitude of 2, now this vector has a magnitude of 1. What if you go to negative 1? Well, this green vector will have a magnitude of negative 1 here, as it keeps decreasing and decreasing. What if it has a magnitude of negative 5? now that's a magnitude of -5. So vectors, and you'll learn this when you're covering polar coordinates. That's one of the key concepts of polar coordinates as well, if you haven't covered those. But vectors that go in the opposite direction, but have the same, I guess they're still a straight line. If they both start at the origin, they're still parallel. So that's another thing that you have to look out for. So this was just an introduction to perpendicular and parallel vectors. You'll figure out ways to see or solve for vectors if they are perpendicular or parallel using some equations. But this was just to give you some exposure for what they are if you're confused about what the rules of parallel vectors are, because them going in the opposite direction, it's a little bit, I guess, can be somewhat confusing. But they don't have to necessarily overlap, is what I'm saying. The parallel vectors don't necessarily have to overlap. And perpendicular vectors, remember, you count the smallest angle between vectors. You do not count the largest angle. So when like a question's asking you to find the angle between these two vectors, you're going to find this angle, not this one. And that should be it for today's video. If you have any questions, put it down in the comments section, and thanks for watching.